Hi, I'm Karen Savage, and I'd like to welcome you to a video series on flood resiliency in British Columbia. I would like to start by acknowledging that this video is being filmed on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. Along with my colleague Diane Meehan, I am co-author of BC Housing's Builder Guide to Site and Foundation Drainage. We have worked with BC Housing and a multidisciplinary team in order to compile and develop flood resiliency recommendations to inform the building industry in British Columbia. These recommendations can be found at the link provided in the video description. We are pleased to present this video series educating British Columbians on flood risk mitigation measures. This series of recordings is part of BC Housing's Mobilizing Building Adaptation and Resilience Initiative, or MBAR. MBAR promotes designing for resiliency of buildings against natural disasters such as flooding, earthquakes, and wildfire. This video series will offer solutions for various types of developments at risk of flooding, including single-family residences, existing multifamily or strata developments, and new construction. This third video in the series will give an overview of different flood risks and provide property managers, owners, strata councils, and occupants of multifamily buildings with information to make their buildings more flood resilient. For a general introduction to flood risk in BC and for information on single-family buildings, including site-specific risk, please refer to the first and second videos in this series. For new multifamily developments, please also refer to the fourth video in this series, which discusses strategies for designers to consider during the design, permitting, and construction phases of new, larger developments, including commercial, multifamily, and mixed-use developments. Flooding occurs when water flows into or collects in a location where it is not expected or accounted for in the design. Understanding and managing flood risk is important to protect our homes, belongings, and investments. As we have seen in the news, the climate is changing, and this can increase flood risk. However, by following best practice flood resiliency measures, we can limit damage from these flood events. It is important to note that floodwaters can be contaminated with harmful substances and can contain disease-causing bacteria and should be handled with great caution. Some common types of flooding you may experience at a multifamily building include overland flooding, pipe backup, and groundwater flooding. You can learn more about these types of flooding in the previous video. In this video, we'll evaluate how these events may impact existing strata multifamily buildings and what can be done to improve the resiliency of these existing buildings. This schematic section provides an overview of some common components of multifamily apartment buildings. The left side of the schematic shows the view of the outside of the building, while the right side of the schematic shows a view of the interior of the building. The features of this section include a below-grade parkade, the above-grade building, the parkade podium, which is the top of an underground parkade, utility connections, and an elevator and core foundation. Note that your building may have a different number of levels above and below grade than shown, but still likely includes many of these features. There are a number of risk factors and mitigation measures for overland flooding that we will discuss in the next two slides. One potential source is when proximate catch basins become blocked. This can be mitigated by maintenance, such as removing debris. Before and after significant rainfall events, drain pipes, gutters, trench drains, lawn basins, and other stormwater collection and conveyance features should be maintained. And if splash pads are used, they should be located as far from the building as possible and set to direct water flow away from the building. Floodwaters may overtop parkade vent shafts, podium slab drains, and the collars of electrical conduits in nearby pad-mounted transformers. Flooding via vent shafts or podium drains can be mitigated by permanently raising the collar or curb or temporarily deploying sandbags. Overtopping of parkade ramps, as highlighted in the image here, will effectively result in a flash flood, which can be expected to completely fill the parkade. The risk of this can be mitigated by permanently raising the crown of the parkade ramp and potentially adding trench drains and/or sea gates. Sandbags can be temporarily deployed during flooding events. Warning or flashing lights at parkade entries can be installed to indicate when not to enter a parkade. Before a flood event, consider flooding in the parkade and the potential for individuals and vehicles to become trapped. Additionally, consider elevator safety, as flooded floor levels may allow for water to enter the elevator. Consider what safety protocols for trapped individuals in the elevator are being implemented. Having a backup generator and fuel on site can help relieve an electrical or mechanical service outage, which results from a flood event. Pipe backup can occur from municipal sewers. Specifically, storm and/or sanitary sewers around your building, as highlighted in the image here, may fail to function as designed and can back up into a building. To mitigate this, backflow valves on sewer services can be installed to limit the likelihood of floodwaters backing up into your building. You can also consider installing a backup pump to divert water elsewhere during an event, and/or restrict flushing of toilets in suites during a flood event to limit the risk of flooding lower suites. Regular maintenance is recommended to keep pipes on your property in working order. Repairs should be undertaken as necessary, and you should consider replacing systems as they reach the end of their design life. If your building has pumps, ensure that there are backup generators available to keep these pumps in operation during a power outage. The fuel for these backup generators should be renewed at least annually to ensure it can be relied upon when needed. Maintenance of below-grade drainage systems is also vital to limit potential water ingress. This in turn limits cracking of foundation walls for below-grade parkades or basements, which may result from hydrostatic pressures acting on the exteriors of the wall and exceeding the design wall capacity. The circular photo shows an example of a horizontal crack in a foundation wall, which indicates that the wall's structural capacity to resist exterior soil pressures has likely been exceeded at some point in the wall's loading history. Note that this hairline crack has been edited in the photo so that it can be appreciated. Evidence of water ingress can manifest as efflorescence, which is a white powdery stain on concrete walls or floors, as shown in the photo on the right of the screen. Epoxy injection may seem to be helpful to fix the situation, but it is often only a temporary solution, with cracking recurring once the hydrostatic pressures build up and exceed the wall's structural capacity again in the same place or elsewhere. Consider building back better after an event or during renovations to accommodate for flood-resilient design strategies. Opportunities for this could be identified within a Strata Council's deficiency report. You can educate owners regarding improving building adaptation and resiliency prior to and following a flood event. Some of these resiliency improvements could include a more resilient landscaping design, raising electrical outlets, and sealing access points where floodwaters may enter the building. There are several different recommendations that Strata Councils, property managers, and owners can undertake to maintain their property. Some common risk factors we see are included here. It should be determined to where the roof discharge is directed. If it is directed to perimeter drainage comprising perforated pipes, this could add water at the foundation level and increase the risk of water or moisture ingress. If it is directed to ground surface, as shown in the photograph to the right, splash pads or extensions to the downspout should be added so that water is directed away from the building. Ideally, roof runoff would be directed to a system of solid piping, which is separate from the perforated perimeter drain pipe. Next, check the function of pumps, alarms, and backflow valves to ensure the system are in working order. Additionally, all accessible drainage features should be checked and maintained on an annual basis. Sumps often become buried within landscaped areas. You may need to consult original design drawings in order to find and maintain these important elements. The Strata Council and Property Manager can look into preparing a complete list of building elements with associated design or useful service lives so that the servicing and renewal or replacement can be scheduled. This can support preparation of a comprehensive maintenance and operations manual. Consider putting together a schedule of regular maintenance items and obtain a maintenance contractor. Identify potential improvements to which manual backup can be added and opportunities for retrofits and building back better. A sample maintenance schedule is shown here. It lists key stormwater management elements that should be maintained regularly. Each property may have a slightly different priorities and timelines for maintenance. If your property is an older building, determine whether the perimeter drainage has been maintained in the near or distant past, or not at all. Additionally, you can advocate for off-site maintenance of sewers owned and operated by the municipality in which you reside, especially if there is a history of backing up. Finally, ensure the strata and owners are protected with appropriate insurance for the identified risks. Some key recommendations for strata councils and property managers to maintain the property for which they are responsible include separating the roof runoff from perimeter drainage where it is combined, and ensuring splash pads and roof downspouts are secured in the correct locations and orientations so as to direct water away from the building. If the parkade has active signs of moisture ingress, consider engaging a professional to look into risk assessment and renewal options. If the podium membrane is scheduled for replacement, it would be prudent to assess the function of the perimeter drainage so that targeted maintenance and repairs can be carried out when perimeter excavation is already partially advanced. Finally, I'd like to invite you to review the BC Housing Builder Guide to Site and Foundation Drainage. Although authored for Part 9, single-family buildings, many of the concepts and strategies discussed are also relevant for multifamily buildings. A link to the online PDF can be found below. This video is the third in a 4-part series. The next video touches on mitigating flood risk for new developments, including larger multifamily, commercial, and mixed use. We hope that this video has offered you new insights related to flood risks and planning for flood-resilient communities and homes, and that you will join us in future videos.